Associate AI Engineer for Developers. Now we're in the 5th course. And this 5th course, we're going to come back with OpenAI API. We're going to develop AI assistants with OpenAI API. So we're going to show you here the screen. I'm just going to check that the audio here is good. So we can screen. Yeah, it's good. It's good. Let's come here and start. Now here I'm gonna create a AI systems open AI systems. All right, now let's start with it. This is our 6 days. This is our 6th day. Our 6th day of taking all of these courses. So let's go.
Hello and welcome to the course. I'm Francesca, and together we'll learn about best practices for developing real-world AI systems using the OpenAI API. So far, we've explored making requests to the OpenAI API model using the Python OpenAI library, calling the API, and extracting the response to access the output. To connect to the OpenAI API and request the use of a model, we initialize an OpenAI client, create a request to the chat completions endpoint, and specify the messages to send to the model, including the role and content. Finally, we extract the content returned by the model from the API response. In this video, we're going to delve deeper into the foundations of structuring an API call for production environments, a key step towards fully leveraging the capabilities of the OpenAI API. Picture developing an AI application as navigating through traffic. A basic API call is like choosing a route on a map without much consideration for the real-time changes. For efficient and optimized navigation, a well-structured API call is like utilizing a GPS system, specific, responsive, and ensuring a safe journey to your destination. When integrating with more complex production environments, we may need additional features. Our API call should be able to handle errors in a user-friendly way by displaying easy-to-understand error messages and proposing alternatives for when the service is unavailable. It should include moderation and safety features, such as handling of unwanted inputs and safety of ingested data, including minimizing the risk of data leaks. It should also include testing and validation to avoid responses that are out of topic and inconsistent behavior. Finally, it should be structured to easily interface with external applications, functions, and APIs, optimizing response times. But before diving deeper, let's first have a look at how to structure an OpenAI API call to request a more standardized output. In order to better integrate with external applications, it is preferable to output the model response in a format that is easily recognized, such as JSON. This way, other functions in the pipeline can easily access the results. In this example, we're asking to list 5 trees with their scientific names. This can be done by specifying the response format parameter that can be set to formats such as JSON and text.
Just in case, this one is new one. This one is a new parameter that we're passing. Response format type JSON object.
Setting it as type JSON object allows us to extract relevant data when communicating with external applications. In addition to the parameter, note that we also specify the format in the prompt. For chat completions, the response is an object from which we can access different elements, including the response message, by accessing the first element of choices, then message, content. In previous courses, we have seen responses as unstructured text, but when using JSON mode, the message content will be structured as asked in the prompt. Now that we've covered the fundamentals of structuring an API call, we have made the first step on the journey to creating a successful AI application on the OpenAI API. In the rest of the course, we'll explore more ways to ensure smooth integration into production, using the API to interact with external functions, as well as follow best practices to build our code. Just like a well-planned route, a well-planned and executed API call sets the stage for a successful AI application. And now, let's practice.
Nice. So here in the code, in the response, was response choices 0 message content. Yeah, it was. I the correct way to select the content. The message only. This one. All right. So here it's a way that we can call the OpenAI. So here I can call client.chat.completions. Create. It creates this. I need to specify the response format, and then here I need to put this, the type object. And then the type is the JSON object. And then here I need to like this, and should be alright, I think. Okay, so I need to do open AI client, I assume. Open AI client is not defined. Why? It's just like this, open AI. Print response. Response choices. So if I do response choice, so I need to do choices 0 content and find the error. So it's inside message. And here it is. Now it's in format, in JSON format. Okay, it generated a JSON form. So here I specified the JSON object, but I didn't specify the structure. It's interesting because it could have generated any other structure. But anyways, to start, it's good. This is called coach. So this is going to be one for formatting model response.py. Now we're going to go here from the OpenAI intro. From the second course, we learn how to I already imported client with all of this. Here in this package, I already imported the environment variable with the OpenAI key, so I don't need to do that again. Just for simplicity, I'm gonna just copy this here and here, and I'm gonna copy this here. Then I'm gonna copy this code. I don't need this line because I already have the client from the other file. And here should run the same. I'm just gonna run this just to make sure I am getting the proper response, and then we can jump to the exercise 2. Nice. So let's jump into the next one. I'm gonna submit first here to check if everything is correct. Everything is correct. Handling errors.
Welcome back. As we integrate the OpenAI API into other projects, encountering errors will be inevitable. Understanding the different error types and their causes is crucial for effective troubleshooting. Error handling isn't just about understanding issues with the code. As AI systems are typically complex, simplifying the user experience becomes particularly important. It eliminates potential barriers to using these systems. For example, in the case presented here, our code uses correct syntax, but we have specified a model that is no longer supported, and so the function won't run. Errors such as this one can be handled in applications in such a way to minimize the impact on the end user.
So here I'm trying to use the model, but here the model doesn't exist or is deprecated.
Let's begin by examining a few of the error types in the OpenAI Python library and the respective solutions. Errors that occur due to connection or server issues on either the user's or the services side are, for example, internal server error, API connection error, and API timeout error. In these cases, the best solution is to check our connection, including any firewalls that might be blocking access, then wait and retry after a few minutes, and to get in touch with support if the error persists. Errors can also occur due to limits to the size or frequency of requests, such as rate limit error and conflict error. Here the solution is to ensure that the requests are paced within the limits of the API, such as reducing the amount of text in the request sent or staggering requests if they are frequent. Some errors will more likely require fixes that we can implement within the code. For instance, in this example, we're passing an invalid key for authentication. An authentication error occurs when our API key or token is invalid, expired, or revoked. To resolve this, we need to ensure that our API key or token is correct and active, and that its access has not been revoked. If the key has expired, we may need to generate a new one from the OpenAI account dashboard. A bad request error indicates that our request was malformed or missing some required parameters, such as in this example, where we're passing an invalid role to the message dictionary. To fix this error, we should review the error message, check the documentation for the specific API method being called, and ensure that we're sending a valid and complete parameters as input to our request. One example where this error may occur could be if any of the required keys were missing from the message dictionary, such as in this example where the message role is neither system, assistant, user, or function. To manage unanticipated exceptions, we use try and except blocks to allow our program to continue to run. Let's take a look at an example. By encapsulating our function call within a try block, we attempt to execute it. First, there is an attempt to execute the code within the try block. If an error occurs during this execution, the code looks for an except block that matches the type of error that occurred.
So it's making a try catch block. So yeah, I'm identifying the errors there, and I'm printing the error instead of just like breaking the code.
If we encounter errors specific to the use of the OpenAI library, such as authentication or rate limit errors, we can use the except block to catch these particular exceptions and handle them accordingly. If a generic error occurs, the code moves to the last except block, allowing the program to continue execution without disruption. Let's practice recognizing and handling some error messages.
Okay. So you're debugging an application that makes requests to the OpenAI API while debugging. You run into the following errors. Identify their definition and possible solution among choices presented. Your request is missing required parameters and some of the parameters are invalid. So it is a bad request error. Double check the variables and parameters you're passing as input and ensure they're valid and in a correct format. Double check the variables and parameters you're passing as an input and ensure they're valid. So this is a bad request. Everything was invalid this part, so this is an authentication. So this is authentication. You have exceeded the number of requests, this is a rate limit. Decrease the number of requests you're sending to the API within a given time. It's a rate limit error. Okay. So now, okay, we're gonna put this in a try and catch. Well, try catches in JavaScript here is like except, I think. This is respond choices 0 message. It's really funny because before I didn't really memorize this. It's just like by repetition I memorized that now this is this is the solution, and this is gonna be the same here. Client chat completions create. It's not that I just by default start learning that it should be like this. It just like happened. So I'm just running here a basic exception. Why is inconsistent use of tabs? I don't think this is inconsistent. I think I need to just reload. Hmm. Okay. Okay, maybe maybe it was the maybe it was this comment that was before. Anyway, now I'm gonna do this handling exceptions. So there's gonna be 2 exceptions. And here I'm gonna do this. I'm gonna do the handling exceptions. And here is my message, but I'm just gonna copy this as a sample messages. So it's just one message, so I'm just gonna copy one. So like this. message here. Here I'm gonna catch the response. So you can see the error here. So I'm gonna do like this, 1, 2, 3. And I'm gonna run this to check Python 2. OpenAI is not defined, so I need to import OpenAI from here. So yeah, it catch the error, so it went here. There's more complex ways to catch the error, but in this way I just catch a general error. Now I guess that in the next one we're gonna be more specific on what we want to catch, what we want to accept. The authentication error. Aha. So I'm gonna take a hint. So if I catch this OpenAI authentication error, all right. So I'm actually in this exercise I'm actually catching the a specific error. Let's wait a second until I see this. I'll just wrap.
Welcome back. We're now going to dive deeper into the rate limits error. Handling this error will help us maximize the request to the API while minimizing delays and avoiding failed responses. Let's get started. Rate limits in an API are like traffic regulations on a busy highway. Just as traffic lights, speed limits, and lane restrictions are in place to ensure smooth and safe traffic flow, rate limits regulate the flow of data between users and the API. By avoiding single users from making excessive requests, rate limits can prevent malicious attacks, as well as ensuring a balanced distribution between users within an organization. A rate limit error can be due to either the number of requests in a given time span being too high, meaning there are too many requests being sent, or the number of tokens in the request exceeding certain limits, meaning too much text has been included in the request. Some solutions to avoid these limits include performing a short pause between requests, setting the function to retry in case limits are hit. If the frequency of the request is hitting the rate limit, multiple requests can be sent in batches at more staggered time intervals. This is referred to as batching. If the tokens limit is hit, the number of tokens can be quantified and reduced accordingly. When sending requests that might go above the rate limit due to their high frequency, we can set our function to automatically retry in case the limit is hit. One way to approach this is by adding a retry decorator using Python's tenacity library. A decorator is a way to slightly modify the function without changing its inner code, and the retry decorator is used to control the extent to which the function should be run again when failing. The wait parameter can be configured through the wait random exponential function. Using the exponential backoff mode is a way to automatically retry requests with gradually increasing delays from a minimum in this case of 1 second to a maximum value in this case of 60 seconds. The stop parameter can be specified using the stop after attempt function and specifying the maximum number of tries. To use the decorator, we'll have to wrap our response request as a function, such as in this example where we have a getResponse function returning the message. If the rate limit is hit due to the timing of the requests and not the number of tokens, one way to avoid it is to send the request in batches. In this example, we're asking the API to return the capital city for each of the countries given, through a list of dictionaries passed through the API. Notice that in this case, we have specified precise instructions as the system message, in order to get a full answer with all 3 responses. This is a much more efficient approach than looping through the chat completions endpoint, passing one country per iteration. Another way to avoid rate limit errors, if the time frequency of requests is not an issue, is to reduce tokens. Tokens can be thought of as chunks of words that constitute units of a word. One way to measure tokens in Python is to use the tick-token library. This way, we can first create the encoding using the encoding for model function and selecting the model we're using, and then count the tokens in the prompt, such as in this sentence we have in this example, using encode and obtaining the total number using the len function. Each OpenAI model has different limits to the number of tokens that it can handle in input, and this also constitutes a way to check that the prompt is below those limits. And now, let's have a look at some use cases to apply the techniques we have just explored.
Got it. Avoiding rate limits with retry. Whoa. So I should do it from. I need to import the tenacity library. So if we import the tenacity library, so I need to import retry. We need to wait exponential, wait random exponential, and stop after attempt. Then in here, I will need to use the decorator of the function so it executes the retries. And I'm going to take a hint because it's the first time I've seen this. No. So I need to do this wait random exponential min max. So I need to define 2 parameters, wait and then stop. And in the wait random exponential min max. Can you explain more the part of the retry in this code? So, well, this is the decorator. You put the wait here, you put the parameters, the wait and the stop is coming from the tenacity library, and the wait randomness for exponential is also coming from the tenacity library. First gets response. Waits roughly twice as long as the previous one. So the first one is 5, the second is 10, the third one is 20, is increasing exponentially, so double is log of 2, and then it's gonna stop after 4 attempts, so it's gonna be 5, 10, 20, and 14. That's all. So let's see how this runs. Stop after attempt is not defined. What do you mean it's not defined? It should be like this. So the solution was wrong. Well, that's new. Okay, so then I need to. I'm just gonna. I'm gonna do this. I'm going to import this here. I'm going to copy this here. I'm also gonna import the client. I can delete this and then I can pass the model the message to get response. I import the tenacity library. There's retry. And then, well, coming to the previous exercise. Okay, first I'm gonna correct this code, okay? Of the previous exercise, because I don't know what's going on. This code. I'm getting this error. This code. This is the here. So it's saying that the authentication it has not attributes, so it doesn't exist. So I need to import OpenAI. So here I need to import. Oh yeah, because because in here I defined I imported the OpenAI from the OpenAI, but I didn't import the whole library. Here now I'm importing the whole library, and then from that whole library I can call that authentication error, and then when I run it, it should be alright. I'm gonna also consider that for here. Also the same in the third exercise. Yeah, everything should be good. It's just that here I made it fail on purpose, so I can actually jump into this line, so I can show you the error. And in the third, I think I'm gonna specify something like this: mini, and yeah, I'm gonna do Python 3, and maybe it's gonna I'm gonna make a print, and I'm gonna put here trying. No more like tenacity. So I should do here pip install tenacity. So if I run this again, now I should be able to see the So I got an error here, but maybe this I don't see any trying text. I got an exception here, but I don't see any text. I don't see that this is printing many times. So I'm gonna ask, why does is it not retrying here? I guess it's maybe because this tenacity is just retrying on because of where is the print. Because of the fact that it failed here. Yeah. And so I'm gonna put it for, so he's trying that, he's trying after 5, 10, 20, and 40. The only thing is that, yeah, because it was somewhere here, it wasn't reaching this because it was failing already here in this line. It just makes sense. Yeah, it executed all of the tries. So okay. So I'm also going to. So here's the retry, here's the catching. Let's just leave it there. So now we know we're trying. And now let's jump right into the next one. Now, batching messages. You're developing a fitness application to track running and cycling training, but find out that all of your customer distance have been measured in kilometers and you'd like to have them also converted in miles. Decide to use the OpenAI API to send requests for each measurement, but I want to avoid using a for loop that will send too many requests. So you decide to send a request in batches specifying a system message that has the converted measurement from kilometers to miles. Present the results in a table containing both original and converted measurements. The measurements list containing a list of floats, and the get response function has already been imported. So the messages should be first. First dictionary should be a system one, and should have content. Then the then in the messages append I should do another dictionary, which is the user. Should be the, sorry, the role should be user, and then the content should be say E, and provide a system messages. You are going to receive a list of measurements in kilometers. Please return a table with the values converted into miles. And then I don't know the structure of it, but let's just leave it like there. Let's just run the code. And what do we have here? Name role is not defined. Okay, this is weird. Maybe let's reload the page. Okay, let's explain the error here. Aha, so it's expecting in quotes. I was considering because I come from JavaScript. So maybe now it's a reload message. Now let's run the code. Explain the error here. And I need to convert this to string. Well, it wasn't explained, I think. What format was it? Contains a list of floats. Okay, so I need to convert to string then response. Okay, here's the table and the conversion. So I'm gonna do this as number 4. Batching. Then I'm gonna copy this. I'm gonna copy it here. And I'm going to run cloud here because I wanted to expand this code. So I have, well, you know what? I don't need that. I think I can just create a measurements. It will be a list of say 5.2, 3.1 and 6.7, and then I just run this into around the 4. It should already be okay because these are floats. Let's not submit this to see what we got. Nice. The get response. Let's get this from here. Because in our environment data cambio was already defined, but here we don't have it that defined. So now we just defined it. Because here we're not specifying the message, so let's just GPT-4o mini. Let's call this here in the model. So we don't need the model. We just pass the message, and yeah, that's all, and then it should be okay. Ah, it's making here. This is not correct. I should pass the messages here now. Okay, that was good. That was good. And now let's jump into the next one. I think it's probably the last one of this chapter for this course. This is called token limits. An e-commerce platform just hired you to improve the performance of their customer service bot built using OpenAI API. This at the start by ensuring that the input messages do not cause any rate limit issues by setting a limit to 100 tokens and test it with a sample input message. So use a token library to create an encoding for. So I think I should define them all here. And then the name of the encoding from model. So I should get wait. So then the input message I should do encode. So technically I think I should put this, or no, encoded that encode. So I guess I should put here the input message. So the encoded message should be here. Here I should get that length. If the number of tokens is smaller than 100, then I should print the response that choices 0 message content. Because of the fact that this I'll explain the error. Encode. Just say the input message content. So in Python is len, I think. Aha. So I should do this as a function. So I should do this. Okay. Okay. So let's submit this. Wait 1 second. Now we're gonna run this into here. And we don't need none of this. And let's run here. Tick token is not defined, so I should run the pip install. Hmm. Ah, ha. Because I didn't import the tick token. Now maybe yes. Yes, so it tokenized it and it's smaller than 100. So if I put like 15, let's say if I get the same issue, my success token limit. Good. Nice. So we finished this first chapter. Now let's take a break, guys. Let's just walk the dog and take breakfast, and we're gonna come back with the second chapter in the afternoon. So let's see you later. Good.